make sure we didn't just add those theta hats together. We had to convert both of them to I hats and J hats, which is exactly what we did over here. We had two different theta hat directions. I had to convert them to I hat and J hats before I could add them together. So a lot of the skills for this problem are similar to what we have over here. Here we've merely studied a rolling wheel, not all that exciting. The one thing we can take away here is that if somebody is standing at point B, point A appears to be moving compared to point B, and vice versa. Compared to point A, point B appears to be moving. In fact, it's got exactly that velocity. Do you think, if you were staring, suppose this is Edgardo standing here, and we've got Zach standing at point B. Is it possible, from Edgardo's perspective, that Zach will appear to be moving further away? No. James says no. What are the rest of you?
I'll say yes.
Trying to get sequences all the time.
What do you think, Fred?
Because I'm moving slower, right? I'm moving slower, and as Zach starts moving.
Yeah, but they're always heading this way.
No, but I'm moving slower in the edge. So that's why it's going to appear that it's not, but it's going to appear that he's moving further away from me.
So Edgardo's saying, well, he's moving
He's going to spin
at
around.
a different speed than Zach, so therefore maybe he could seem to be going further away. Seems reasonable enough. James, you want to give a reason why you think Edgardo might be wrong?
Well, I mean, point B and point A are always going to be the same distance apart, even though they're both spinning at the same speed compared to C. So there's no way like the circle's going to shift. They're both fixed. So we're both going to spin. You know.
No, but he has, it appears, I'm not saying, he's actually moving.
Well,
He has it
Well, what I mean by appears, like if I could have a ruler, if you two are, here's the disc right here. If you got out a ruler,
Well, technically I'm not. Then technically
exact.
no. Then no.
Yeah, no.
if
But
you
you
were
said
just looked
appears.
at it, would it look like he's going further away, or coming closer at you?
It will look like he's getting away, but he's not.
It's not going to look.
I don't think it would look that way.
Isn't it? No.
It's kind of like
A is taking
Ed's thinking in A.
It's like you're on a Ferris wheel.
Zach said.
yeah.
You
One
know,
of those,
doesn't look like he's
Yeah,
closer
it's kind of
or
like
further away.
being on a Ferris wheel,
Or
and staring at some
a
point in the
merry-go-round.
machinery. Yeah.
Yeah.
So Edgardo, I'm glad you raised it, because actually James is really the only one that answered quickly on it. So you gave kind of the other side. If I'm looking at James or you're looking at Zach, the distance that he is from me will not appear that he's going further away, nor will it appear that he is coming towards me. But he will appear to be moving. In fact, there's the speed right there. Boom. So the question is, which way, what's left? So if he can't look like he's going further away, and it can't look like he's coming towards me, which way will he have to appear to be moving from my perspective? He'd have to look like he's either going that way or that way. He can't be going further away, and he can't be coming closer. So what it'll look like James is doing from my perspective is look like he's going sideways, and if I went to another instant later, he'd just keep going sideways. It looks like James would just be doing circles around me. And in your case, between these 2 points, it'll look like from point A, this guy's just going around and around. And from this guy's perspective, it'll look like that guy's going around. What I haven't proven, but what is absolutely true, is they will all appear to be going round and round at 5 radians per second. That rotation is the same for everybody on this object. So it's not like the rotation is 5 compared to the center, but 10 for 2 points on the outside. And maybe that makes some sense. It can't be different for different points. Maybe this is another chamber of secrets, this rolling wheel. There's a lot there. We could go a lot further. We haven't even touched accelerations yet with this. And I haven't done accelerations yet with this. But what I would like to do, I think you have the pieces necessary to solve this problem for velocities, not accelerations yet. So on computer computer exercise number 21. One of the problems that you have to do is to solve this for velocities, not accelerations yet. So go ahead and fire up session 21.